The question here is asking us to determine the tension developed in each one of those cords. If the lamp here mass is equal to 20 kilogram, so we will convert this 20 kilogram into Newton by multiplying it by 9.81. So we will keep D in equilibrium so that we can find DE, the tension developed in DE, and DC. Then we move to keep C in equilibrium. Then we to determine the tension developed in CB and CA. So to do that, starting with our sign convention. The first thing in here, we're working with our sign convention. The sign convention that we are going to work with, we keep these directions for positive x-axis and this one positive y-axis, and if we're dealing with moment, anti-clockwise will be positive. Then we will start with our free body diagram, the first free body diagram to keep D in equilibrium. To keep D in equilibrium, we draw the free body diagram in here. Since D in equilibrium, then D will be our origins in there, and we know that there is a force developed in here, or tension developed in here from D to E, and this is at D to E, this is at 30 degrees from the positive x-axis, and we have D to C, DC in here, another tension force developed from D to C, and we also have the weight of the lamp itself downwards straight on the negative y-axis, and that's this force in here, it's 20 kilogram mass, multiply that by 9.81, which will equal 196 Newton. Once we finish with our free body diagram, we try to apply the equations of equilibriums. Equation of equilibriums. Sum of the forces on the x-axis should equal to 0. Starting with this one here, for the x component of DE, that will be cos FDE cos 30. So FDE cos 30, and on the negative x-axis here we have FDC, so minus FDC, and downwards we don't have any x component for the FD, that's F in here, so FDF doesn't have any x component, therefore that's it for this diagram in here, that these all should equal to 0. And from here we know that cos 30 is equal to 0.866 in here, FDE minus FDC equal to 0. Let's number this equation here with number 1. Now we sum all of the forces. Sum of the forces on y-axis should equal to 0. So sum of the forces in the y-axis for DE will be FDE sine 30. FDE sine 30, sine 30 degrees. Sine 30 degrees. And for the second one, FDE doesn't have any y component. Downwards it's got negative 196, so negative 196 Newton. These all should equal to 0. From here we know that sine 30 is 0.5 FDE equal to 196 Newton when we take this to the other side. So from here we can find FDE equal to 196 divided by 0.5, 196 Newton divided by 0.5, which this will equal to 392.4 Newton. This is for the FDE, this force in here. What about FDC? For FDC, we will take this one here, FDE, and substitute this one here. Let's call this is 2. Substituting 2 into 1. So sub 2 into 1. So to substitute 2 into 1, this is the first equation here. So we have 0.8 FDE. FDE itself, we found it to be 392.4 minus FDC equal to 0. From here we can say that FDC equal, when we take this to the other side, just multiply these two here together, and this is of course in Newton. So when we multiply these two together, we get 339.8 Newton. So this is FDC. Now we will move to C to make it in equilibrium. So once we come to C in here, we will make another free body diagram to make C in equilibrium. So this is C in equilibrium, and of course we have DC in this direction here because the rope is being extended in this direction, or sorry, the rope developed tensions in these directions in here towards D. And we also having here to A, CA, and CA in this case has got special or similar triangle 4, 3, 5, and we also have B in this case, which is developed at 45 degrees if this is Y in this case. So basically this is our free body diagram. Again, we apply the equations of equilibrium. So the sum of forces on the x-axis should equal to 0, and the forces on the x-axis we have on the positive x-axis FCD, which we just found to be 339.8. So let's make it 340 roughly. This one here, it's roughly 340 Newton. So FCD, which is 340 Newton. And for the FCA we have the x component 3 over 5, but it is negative 3 over 5 FCA. And then for the other component here, to get this component, the component of SCB on the x-axis, it's again negative. This will be, we make this here 45, then we can take it, these both angles here are equal, so we can say negative FCB cos 45 degrees. Or also guys, you can get it from the by the other side, and there you can get it the sign as well, because both exactly they're going to be the same. But in this case we say in here FCB cos 45 degrees, and this is for the x-axis. These all should equal to 0. So try to simplify this. So 340 Newton minus 0.6 FCA minus cos 45 0.707 FCB, they all should equal to 0. From here we can say that, simplify it further, negative, or we take this to the other side, 0.6 FCA plus 0.707 FCB equal to 340 Newton. Now these are the sum of the forces on the x-axis. Let's number this as number 3 in this case. So let's find the sum of the forces on the y-axis. They all should equal to 0. For the y-axis here we don't have anything for D, but we have here 4 over 5 for FCA. So this one FCA 4 over 5 FCA minus, for the CB here again sine or cos, they both will work, so minus FCB sine 45 degrees. When you do that, minus FCB 45 degrees, and we don't have anything on the y direction, from here we can say this equal to 0. So 4/5, it's 0.8 FCA minus 0.707 FCB. That should equal to 0. From here we can solve for one of them. So if I'm going to solve for this, for the FCA, either one of them, they should be okay. So 0.8 FCA equal to 0.707 FCB. So FCA equal to 0.707 divided by 0.8 FCB, which equal to in this case 0.88 FCB, and let's call this one here or number it as number 4. So substitute 4 into 3, so sub 4 into 3. When we do that, when we substitute 4 into 3, so we have FCA 0.88 FCB. So let's come in here 0.6 FCA. FCA, it's 0.88 FCB plus 0.707 FCB equal to 340 Newton. So multiply these two guys here together, and we should get 0.6 times 0.88. Let's do that on the calculator. 0.6 times 0.88, that would be 0.528 FCB plus 0.707 FCB, which equal to 340 Newton. So add them together and they both should equal to 1.237 FCB equal to 340 Newton. So FCB, which what we're looking for, should equal to 340 divided by 1.237. This will equal here 274.8 Newton, which is roughly 275 Newton. We can do that. So now we found FCB, we can substitute back into 3 or 4 either to find FCA itself. So substitute into 3, substitute that into 3, substitute this value in here into 3. So 0.6 FCA plus 0.707 FCB, and FCB we found it to be 275 Newton equal to 340 Newton. Now just multiply, plug these values in your calculator in there. 0.6 FCA plus these two values in here should equal to 194.3 equal to 340 Newton. So FCA equal to 340 Newton minus of course this one in Newton as well, minus 194.3 Newton. These all divided by 0.6, and this one should equal 242.8 Newton, which is roughly you can say 242 243 Newton. And this is how you solve this question, guys, and show your step-by-step solution or working out, so that you don't miss any marks